Hi, thank you for joining my presentation. I hope you have been enjoying AROS Innovation Week so far. Today, we will be talking at how we save lives in public safety solutions using artificial intelligence and serverless architectures. My name is Ioannis Kolaxis. I am a software architect and a distinguished expert. I live in Athens, Greece, where I work for UCC Public Safety Solutions. And we have a team, a development team, that works on building a web application called GEMA, Global Emergency Management, that is being used by call takers, by emergency call takers in North America in order to handle emergency calls. If you were an eyewitness at an emergency scene, like the fire shown in this photo, what would you do? Would you call 911? Of course, in case of emergencies, we always call 911. The call taker would ask some details about this emergency incident, such as the kind of fire. Is it a building or a car that is on fire? And would also ask if there are any humans whose lives are in danger. And then you would have to wait for the fire trucks to arrive and extinguish the fire. How much time would it take for a fire truck to arrive? Can you guess? Is it 1, 2, 3, 4, 5 minutes? Or is it more until a fire truck arrives? Well, if you were in New York City, then we know exactly how much time it will take for the fire truck to arrive. According to this official data provided by New York City, if the fire were a structural fire, then it would take approximately 4.5 minutes for a fire truck to arrive on scene. When we talk about structural fires, we mean about fires in buildings, home buildings, office buildings, and so on. Whereas if the fire were a non-structural fire, such as a fire in a vehicle, then it would take approximately 5.5 minutes for the fire truck to arrive. As you can guess, the response time is an important metric that can make a huge difference between life and death, between the number of people we can save in an emergency. The higher the response time it is, then the more likely it is that we have more casualties, that we have more deaths. The lower the response time it is, then it is more likely that we can save more lives. That's why it is important that we have low response times. Let's have a closer look at this table that will help us have a better understanding of response times. When we first call, an emergency call taker will pick up the phone and ask us about the nature of the emergency. When we tell them that it's a fire that we wish to report, then they will transfer our call to the fire department. At the fire department, they will ask more specific, more targeted questions regarding the type of fire. And as we answer and provide data, the call taker at the fire department inputs this data in a computer. It creates a job, a dispatch job. As soon as this dispatch job is complete and registered at the system, only then can a fire truck be dispatched to the emergency scene. As you can see, it takes approximately 1 minute and 15 seconds until this process of creating the job on the system is complete. how could we minimize this time? Is there something we can do? Nowadays, we all use mobile phones in our daily lives in order to communicate with our friends, our family, our colleagues. According to the official data provided by the state of California, the same happens with emergency calls, where more than 80% of the emergency calls originate from mobile phones, from smartphones. However, although we use our smartphones to send photos to our friends and family, when it comes to emergency calls, we just place a plain old audio call. But is it necessary to place a phone call to 911? Could we send them a photo instead? As you are probably aware of, our mobile phones always know our location. Especially when we take a photo, our location is also embedded in that photo. When we look back to a photo that we've taken some time ago, we can always identify the location where this photo was taken. This means that if we send our photo to 911, a software application would be able to extract the location from the photo and display it to the emergency call takers. Let's assume that 911 has already received the emergency photo that we just sent them and have successfully extracted the location from this photo, being able to precisely identify our location. What happens with the evaluation of the photo in order to see if there is a fire or something else going on in that photo? Do we need a human? Do we need a call taker to do this job? Or could we have a robot instead? AI can automatically analyze photos sent to 911 in order to classify them in emergency and non-emergency photos. It can also detect individual objects in the photo, such as fire. When a fire is detected in a photo, then this can trigger a notification to be sent to the fire department so that they dispatch a fire truck to the emergency scene. Is it realistic to replace a human, a call taker, with a software that uses AI? Is this something that we can build today? Or is it something envisioned to happen in 20, 30, 40 years or even more from now on? As you can see here in this slide, most public cloud providers already provide turnkey solutions that empower us to implement this solution today by using pre-trained machine learning models that analyze images for us. Therefore, this solution is feasible. Let's take a look at an actual example. Here, we used Google Cloud's Vision AI in order to analyze our photo. As you can see, this tool has identified an object, a bus, in our photo. It has also assigned some labels to this photo along with a confidence expressed as a percentage. Some of the labels identified are fire, flame, heat, explosion, and so on. And we didn't have to customize this tool or invest any effort. This is the analysis that is provided out of the box. Isn't this impressive? What kind of hardware will we need to run our AI image processing algorithms? Do we need an expensive data center that is packed with servers? Of course not. We will not need a single server to host our solution thanks to serverless architectures. In a conventional solution, we would need at least a server that would be continuously running our application, consuming resources day and night, even if it were not serving any requests. On the contrary, in a serverless architecture, in a serverless solution, our application runs only when there is an incoming request, that is, an emergency photo, an incoming emergency photo that needs to be processed. If there are not any pending requests, then our application shuts down, saving us resources, valuable resources. Serverless allows developers to focus on their code, to focus on writing and maintaining code, instead of worrying about provisioning or managing servers. Moreover, serverless automatically handles scaling for us. When we have a lot of incoming requests, that is, a lot of incoming photos that need to be analyzed, then it automatically scales out our solution by spinning up more instances. And when these photos are processed and we don't have any incoming photos to be processed, then our system automatically scales in our system, reducing the number of running instances. And if we don't have any incoming requests, then it will shut down every single instance of our application, thus saving resources, saving money. If someone asked you, "Is this a viable solution?" what would you answer? Serverless is best known for its low operational costs because cloud providers charge us only for code execution time, that is, only for the time taken to process each image received. Clearly, this creates a great opportunity for us to apply new, innovative billing models that we have never thought of. Therefore, we can charge emergency services only per photo received and processed by our solution. Here comes the million-dollar question. Why would a customer consider buying our solution? Because it has a great potential to save more lives by helping emergency services respond faster to emergencies. That's why. If we assume that it takes a second for our solution to process an incoming emergency photo and create a dispatch job, then we reduce response times by 23 or 27% depending on the case, as illustrated in this table here. Our solution can be attractive to customers thanks to its innate ability to handle large-scale events where hundreds or even thousands of eyewitnesses may be sending photos about an emergency incident that is in progress. Furthermore, our solution can be enhanced to automatically correlate photos originating from the same event, referring to the same event. Can traditional call centers do the same? Concluding, our solution has all the characteristics of an innovation: desirability, feasibility, and viability. Why is our solution desirable? Because our customers, emergency services, want to save lives, and by reducing response times, we'll help them achieve their goals. And why is our solution feasible? Because we don't have to reinvent the wheel, but we leverage AI and serverless as provided by public cloud providers. Last but not least, our solution is viable because serverless architecture offers low operating costs, and it also gives us the opportunity to offer new, innovative billing models to our customers, charging by photo received and processed by our solution. Now is the moment that you've all been waiting for. Demo time. So, what are you waiting for? Grab your phone, scan the QR code shown in this slide, and send your emergency photo to our proof of concept. As you can see, we have created an email account especially for Atos Innovation Week. If you wish to type this instead, the email is atos911 from the future at outlook.com. Your photo will be automatically processed by our software application, and you will receive a reply that will include the analysis of the photo and the actions that our solution has taken. So if there is a fire illustrated in your photo, in your emergency photo, then a fire truck will be dispatched as it will be mentioned in the email reply. But don't worry, a fire truck will not be actually arriving at your location. This is only a demo. No actual fire trucks have been used as part of this demo. Our presentation is not over yet. Would you like to have a look behind the curtains to see how all this works? Let's go! One of the main building blocks of our proof of concept is this Logic app in Azure, which allows us to easily integrate our solution with Microsoft Outlook in order to receive notifications whenever there is a new incoming email with an emergency photo as an attachment. When we go to the Logic app designer view, we can see this graph. The first building block in this Logic app is this action here that triggers our application. When a new email arrives in folder inbox of any importance, having attachments, then we loop through all the attachments and have a special condition here that we wish the attachments to end in JPEG format. That is one of the most popular image formats. And as long as our attachments are JPEG photos, then first of all we execute our serverless function. We trigger our serverless function called image geolocation, which will clearly extract the coordinates. It will extract the location of this photo, and next it will pass the image to this Azure cognitive service called tag image. in order for Microsoft's AI to analyze our photo and assign some tags, some labels, as we have already explained. And then, depending on the tags identified in our picture, some actions will be taken by our application. For example, if fire is detected, a fire truck will be dispatched, and then an email reply will be sent back to us, informing us of all the actions that our application has taken. Azure Logic Apps provide us a detailed history of all the requests processed. For example, here we can see the requests that have succeeded and the requests that have failed. Let's take this failed request as an example and let's click on it to see why it failed. As you can see, we can take a closer look into the step that has failed to execute. This is this image geolocation shown right here. For some reason, our serverless function failed to execute properly. And we can see the inputs that were passed to our function for execution and the outputs. First of all, when we click on Show Raw Outputs, we can see the status code, which is 500. This is an HTTP error code for the server error. And we can also see the headers of this request. Let's close this one and let's go to the inputs. When we click on Show Raw Inputs, we get the inputs that triggered the execution of our serverless function. What you see here in the body is the image that was passed to it, the emergency image being encoded in base64 format. This is the code that we have written in order to implement our serverless function. First of all, you can see its name. It's image geolocation. Next, you can see this HTTP trigger annotation. This means that its execution is being triggered by an HTTP request. Of what type? It's a post HTTP request. And this request will always contain an image, an emergency image. This image will be actually a string, a base64 encoded string. One of the first steps in our code is to check whether there is an HTTP body present in the request. In case we don't find one, then an error message is being printed and we return the HTTP status error code of bad request. In the case that we have a body, then we proceed with our code and attempt to decode this base64 encoded string, this image. As soon as our image is decoded, we read all the metadata from the image. Here we care about the location coordinates in particular. That's why we look for the GPS data embedded in the photo. And we make sure to extract the longitude, the latitude, and the altitude. At the end, we have successfully extracted the coordinates and we send them back to our Logic app that has triggered our execution. If you wish to find out more details about our solution, please don't hesitate to contact me. Give me a call over Circuit or send me an email and I'll be happy to hear from you. Thank you very much for joining my presentation. See you soon. Bye.